Today we're learning about piecewise functions. It's called piecewise functions because it's like we take two or more equations and we look at specific pieces of those functions. So in this example, 2x plus 3 and x squared minus x plus 5. If our x values are less than or equal to 4, we're going to use the top equation. If our x values are bigger than 4, we're going to use the bottom equation. So on the graph, there would be two different lines, and then at 4, it's like the switchover point where we switch from one equation to the other equation. So it's kind of like we're graphing half of each of those equations and then deciding, does this go on the left half or the right half of this switchover line? We also use piecewise functions to evaluate functions. So here we've got f, the function f, and the function h. So now we're below this line. I'm going to draw a nice purple line. There we go. We've got the functions f and h. We want to evaluate f of -3. So that means you're taking the f function on the left and you're looking where is the x value of -3 going to apply. -3 equals -3, so we are going to use this bottom equation. So we are going to use x minus 9. Plug -3 into that. What is -3 minus 9? -12. So f of -3 equals -12. This is just like the evaluating functions you've done before. There's just this added piece of, first you have to figure out which equation you need to plug it into based on the x value. Number 2 is asking you to do h of 5. H is this function on the right. Is 5 less than 6 or bigger than 6? Less than 6. So we're going to use the top function, 1/2 x minus 10. So half of 5 minus 10. And I'm okay with decimals here. What's half of 5? 2.5. And 2.5 minus 10. Oops. Is it -7.5? Yeah. Awesome. Okay, actually, I'm going to use purple to show what we've done. So we used this one for the purple one. We used this one for the green one. If I could actually make my circle look nice. Okay, h of 7. So again, we're on the h function, the one on the right. 7 is bigger than 6, so we are going to use that bottom one, -x minus 1. Negative, then you plug the 7 in, minus 1, which is -8. So h of 7 is -8. F of 2, which equation should we use for f of 2? Which one? 5x minus 1? (5x minus 1). 2 is not smaller than -3. So no, you're right. It is this one again, x minus 9. So 2 minus 9 is -7. F of 2 equals -7. So in that one, we didn't end up using that top left function at all. But if I had given you f of -7, then you would have used 5x minus 1. If I would have given you f of -10, we would have used that top left function. Graphing piecewise functions. You want to use a pencil, probably. And if you like to use colored pens, that's totally fine. You can use colored pens for like the final answer. The first thing I want you to notice is that our changeover, our switchover spot is going to be 2. So at x equals 2, these two functions are going to switch over. So I'm going to put a dashed line at x equals 2 because that's my changeover spot. And I'm going to write in here that my switchover at 2. X is less than or equal to 2. Where on this graph are the x values smaller than 2? To the left of this line or to the right of this line? To the left of this line. So this function is going to be graphed on the left side of the line, which means the bottom one is going to be graphed on the right side of the line. And then this will make more sense once we actually get there. But which of those has the or equal to symbol? The top one has the or equal to symbol. So that one's going to have a solid dot on the line. This one will have an open dot on the line. Okay, so that's like my pre-work that I do. I draw in the switchover line and I think about which one's on the left, which one's on the right, and what kind of dot. Now let's actually graph. So if I graph this one, negative x plus 1. We start at 1 on the y-axis, and we use a slope of negative 1. I'm going to have this one be green for my final answer. We said that this one had to be on the left side of that line with a solid dot. So on that line, I'm going to fill in a solid dot, and then I'm going to use the points to the left and draw in that line just on the left side. And then I will erase the dots that are on the right. So the only piece of this graph that we want is the piece to the left of this x equals 2 line. Now let's graph 2/3 x plus 2. I start at 2 on the y-axis, and it's kind of weird that we're graphing up above and in and around this thing that we previously graphed, but we can do that. Slope of 2, so from that point we go up 2, slope of 2/3, up 2 over 3, up 2 over 3, I'll use pink for this one. We want the graph on the right side of this line. And where the graph meets this line, we need to put an open circle. Here's why one of them must be open and one of them must be closed. This is a function. Do you remember the vertical line test with functions? A vertical line can't touch more than one point. So this line x equals 2, if that pink circle was closed in, then the function, it would be touching more than one point at a time, and that would be bad. Okay, and then I can go back through if you want to like fill in these dots with the pink as well. And I can erase that point that I don't want on the left. So we end up with 2 graphs on the same coordinate plane, but we only want the top one on the left side of this x equals 2 switchover line, and we only want the bottom one on the right side of this x equals 2 switchover line. Okay. Number 6, the first thing I want you to think about is where is the switchover line? The switchover is at 3. So I go to 3 on the x-axis and draw in a vertical line. I draw it dashed just because that line doesn't have to be there. It's really just a visual cue for us that helps us when we're graphing. It doesn't have to be there. Okay, x is less than 3. This one is going to be on the left side, and it's just less than, so that one's going to have an open circle. The bottom one is going to be on the right side, and it has the or equal to, so it's going to be a filled in circle. So my first thing I do before I even touch the graph, before I touch those functions, is I am just looking at this information right here to decide where's the switchover point, which graph is going to be on the left, which one on the right, which one has the open circle, which one has the closed circle. Then we can actually start graphing. Negative 2x plus 6. I want you to pause the video, graph that one. I'm going to have this top one have the final answer be in purple. This one needs to be on the left side, so I want these points on the left. And when I get to this line, I want to put an open circle on the line. Then you can erase the points, if you had any points, on the right side of that line. Now we're going to graph 3x minus 2. You still start on the y-axis. You still start at 0, 0. We're going to go down 2 to our y-intercept of negative 2, up 3 over 1, up 3 over 1. And it's kind of weird that we're crossing, but that's okay. This one, you may need to use your slope several times to get to a point where you are to the right of that line. Okay, I'll do this one, final answer in orange. Sorry about my squeaky chair. This one has a closed circle on that switchover line, and we want the right side of that graph. The stuff on the left, you can erase. The last thing we're doing today is step functions. Step functions end up looking like stair steps. This is very commonly used like for amusement parks. Like kids up to age 3 are $1. Kids 3 to 6 are $2. Kids 6 to 9 are $3. Kids 9 to 12 are $4. That seems like a very extreme price scale, but whatever. Let's do some prep work. The prep work is looking at all these x's. The biggest thing I want you to notice here is that we've got a less than equal to on the left side and a less than on the right side. Less than equal to is a solid dot. Less than is an open dot. Each piece of this graph is going to look like that little chunk right there. Notice it says f of x equals 1. That's a horizontal line at 1. But we're not going to draw the whole horizontal line at 1. We just want the piece between 0 and 3. So 0 up to 3. And I would erase the rest of that line. So there's that little chunk of the graph. Next, we're looking at a horizontal line at 2, but I don't want the whole horizontal line. I just want the piece between 3 and 6. So from 3, 4, 5, 6, open circle at 6. This is going to still pass the vertical line test because notice at the vertical places where there's 2 values, one of them is a closed dot, the other is an open dot. The next one is a horizontal line at 3 between the x values of 6 up to 9. My open circle was a little bit small. And then 4 between 9 and 12, which is off the graph, but we'll just kind of make it work. Do you see the stair step? This is why it's called a step function, because it looks like a set of stairs. I want you to try number 8 on your own, but I'll start you off with the pre-work. This is less than on the left, less than equal to on the right. So that means open circle on the left, leading to a closed circle on the right. So for each of these, it'll look just like number 7, except it'll be an open circle on the left, a closed circle on the right. So pause the video, see if you can try this one on your own, and then play the video to check your answer. If you want to label the x-axis with those numbers that are in this part, that might be helpful for you to see where those steps need to be.